Why does your hair stand up when you rub a balloon on it? Why do tiny sparks jump when you touch a metal door after walking on carpet? And how do two tiny charges, invisible to the eye, coming into the eye, create forces powerful enough to hold entire atoms together? All of this starts with one idea: electric charge. Imagine two kids on swings holding magnets. Sometimes the magnets pull together, sometimes they push apart. Electric charges behave almost the same, but on a much deeper level. Everything in the universe is made of particles with either positive charge, negative charge, or no charge at all. And these charges follow two very strict rules. One, like charges repel, positive versus positive push apart. Two, opposite charges attract, positive versus negative pull together. This attraction and repulsion is why atoms stick together, why lightning forms, and why electronics work. Now, the important part students always struggle with: Coulomb's law, the rule that tells you how strong the force is between two charges. Coulomb's law says, 1. The force gets stronger if the charges are larger. 2. The force gets weaker if the charges are farther apart. 3. The force acts along the straight line connecting the charges. 4. And it behaves almost exactly like gravitational force, but much stronger. Gravity pulls everything together. Electric charges can pull or push, and they do it with insane strength. In fact, electric forces inside atoms are trillions of times stronger than gravity. That's why electrons stay bound to nuclei, static shocks happen, and even your phone battery works. You felt Coulomb's law many times. Rub a balloon on your hair, electrons move, charges build, hair rises. Touch a doorknob after walking on carpet, built-up charge jumps, tiny spark. Clothes stick after drying, charges cling to each other. Static electricity is just Coulomb's law in action. And here's the deeper truth. Every circuit, every wire, every battery, every device, from phones to laptops to power plants, is built on the behavior of these charges. The entire electrical world runs because electrons respond to forces predicted by Coulomb's law. Now here's the curiosity twist. If electric force is so powerful, why don't we feel it pulling and pushing us all the time? Why aren't we constantly repelled or attracted to everything around us? The answer lies in electrical neutrality, and we'll break that in the next lesson.